Hello and welcome back to the Homework Helper. Today we are looking at Lesson 6 from Unit 5, questions 1 through 4 and then 6 through 10. So for questions 1, 2, 3, 4 that we're going to be looking at is going to be involving Figure 1, which is this guy right here. So here's Figure 1. We're going to be using this one for 1 through 4. So let's quickly read over the directions. Conjectures are statements which are believed to be true based on the current data or evidence. However, they have not yet been proven or disproven. To move toward logical proof, true statements that properly build on one another along with justifications for those statements are needed. Based on the diagram in Figure 1, provide a justification for each statement. So if we look at this, we have angle AGB, CGB, CGD, and AGD are right angles. So so it looks like these guys, they want us to see that these guys are all right angles. So do we have enough evidence to say that? Looking at how the diagram was made, it appears to have been made through a construction. So I think that we can say that they all are right angles. So the diagram provides evidence of perpendicular bisector. So perpendicular meaning 90 degrees, bisector means chops it in half. So there's been perpendicular bisector construction. So angles are right angles. Ooh, handwriting's getting worse. Okay. AG, BG, CG, and DG. AG, so that's basically taking a look at all of these, this, and this. That's what we want to prove. And if we look at this circle here, right, that circle there, these are all, if we have a circle G, these are all radii. So all radii are going to be the same. So that's pretty fair. Okay, so we have, going back, we've shown that these 4 angles are all right angles. Right now we want to show ABG, CBG, ADG, and CDG. If you look at each one of these, right, we've got a side, angle, side. So side, angle, side with the first 2 problems. AB, okay, so now we have AB, BC, CD, and AD, right? This is a CP, CTC, which is an abbreviation for corresponding parts to congruent triangles are congruent. So this one right here, 4, builds off of 1, 2, 3. I guess you can just say number 3, right? Because that's the reason why we can say that. All right, so that takes us through 1 through 4. Now let's take a quick look at 6 through 10. Okay, so based on the information, the statements, diagrams, possible make claims what this is likely true. The claims are considered conjectures because they have not yet been proven or disproven. For each problem, use a diagram and statements to generate at least one conjecture about the quadrilateral. Okay, so we know that these two triangles are congruent. So we can say, okay, these angles are going to be the same. These side lengths are going to be the same. These side lengths are going to be the same. So we are dealing with a parallelogram. Unproven, but it looks like these two sides, we could do a little bit of work to say that, but we don't know that for sure. CPCTC with everything else, but we'll say triangle, quadrilateral. TAVR is parallelogram, and I'm going to write it like this. The parallel lines and O-gram. 7. Triangle ABC is congruent to triangle DEC. ABC and DEC. So now we get this and this are corresponding. Okay, so let's see what else we got. Okay. These angles. Okay. So once again, I'm going to say that this is another parallelogram. So what we want to look at, AB, DE. All right, so here, these guys are congruent. There's nothing to, we don't know anything really about this side here, although we can, if we were to do some of these other steps, that would require some things. It doesn't appear that it's going to be a rectangle. There's nothing about right angles or anything like that. So we'll just guess that this is going to be this is going to be a parallelogram. Still lots of work to be done. There's no evidence that would point it to be anything other than either just a quadrilateral or a parallelogram. We just haven't proven anything yet. Number 8. So number 8, we got a couple of things. REH and AEC are congruent triangles, so we get this and this. REH and AEC. Oh, and they're isosceles. So that means that these guys. All right, so we have isosceles. So that means that we have a diagonal. All right, so the diagonal are congruent. Looks like. So if we go back to our, we go back to the things from, what was that, from lesson 4 maybe, where we talked about diagonals and attributes of rectangles, rhombus, and square. I'm going to say that this is probably not a square. It's definitely not a square. It's definitely not a rhombus. So I'm going to conjecture that RACH is a rectangle. And I'll spell this correctly. All right, number 9. This doesn't look like anything to me. But let's go with what we know. We got two congruent sides. There's nothing that indicates that this would be anything. This seems like it's just a... So let's say ACDB. We'll just say it's a quadrilateral. It does not look to be anything else. All right, let's go with the last one for the homework assignment. This is number 10, and this should take us to the end. We get isosceles right triangles. Okay, REH. This one's REH, that means this. Yeah, this one seems... I'm going to guess that the quadrilateral RACH is a square. Right. Once again, haven't proved it. None of these were proved. Right. We're just going by the information that we have. And, you know, some of it's an eye test type stuff as well. Like, we can look at number 7 and say that's not going to be a square. Right. Same thing with number 6. There's still work to be done here. But that's kind of what we can just say. This appears, that's what our conjecture is. All right, so that will take us through lesson 6. I will be back for lesson 10. So I will see you then. In the meantime, good luck and thanks for watching.